Last time we talked about rational expressions. We looked at how to multiply them and how to divide them. Today we're going to look at adding and subtracting. Last time we looked at rational expressions. We looked at how to add them. Last time we looked at rational expressions. We looked at how to multiply them and how to divide them. We used the analogy of fractions. Today we're going to do the same thing. We're going to use the analogy of fractions to help us understand how to add and subtract rational expressions. We've got steps just like we did last time. Factor if possible, that's the same first step. Determine any restrictions, same step. Determine the least common multiples of the denominators, so that's new. Rewrite the expressions with a common denominator and add or subtract the numerators. Again, this is just like fractions. If I had 3 over 5 plus 1 over 2, how would I add that? Well, I need to make sure that the denominators are the same. How do I make the denominators the same? Well, the least common multiple would be 10. I need to multiply this by 2. If I do it to the bottom, I got to do it to the top. I got to multiply this side by 5. If I do it to the bottom, I have to do it to the top. So now my question becomes, oops, let's write it below. 2 times 3, 6 over 10 plus 5 over 10. Determine the least common multiple of the denominators. Rewrite the expression with common denominators. Done. Add or subtract the numerators. In this case, add. 11 over 10. Alright, we're going to do the same thing, but it's going to be x's and x squared and all that fun stuff. Example 1. Simplify each expression and state any restrictions on the variables. Step 1, factor. No factoring. Step 2, restrictions. I look at this denominator here. What value of x would make this denominator equal to 0? X can't be 0. This denominator here. What value of x would make this denominator equal to 0? Still 0. Good. Instructions are done. I need to find a common multiple. Lowest common multiple here would be 10x. What do I need to multiply 5x to get 10x? I have to multiply it by 2. So I have to multiply 1 by 2. Here I'm going to multiply by 5 to get 10x over 5. I add the numerators, 7 over 10x, as long as x cannot equal 0. Sorry about that. Not too bad. Not too bad at all. Second example, and I'm very sorry, but I'm going to have to make a change in this example. A times b squared plus 2 over 2ab, and I'm going to make that a b squared. So can I get everyone to add in? That's b squared. Okay. B squared, it wasn't typed as b squared. My bad, I'm sorry. Minus b plus 2 over 2b. So what's the lowest common multiple? Oopsie. So now that I've changed this to a 2, what's the lowest common multiple? Well, is there anything that I can multiply this by to get to this? I'm missing an a, and I'm missing one of the b's. So if I multiply this by a times b, I'm going to get the same thing here. If I do it to the bottom, I got to do it to the top. So what do I have here? ab squared plus 2 over 2ab squared minus ab times b plus 2 over 2ab squared. Now I've got the same denominator, common denominator. However, I've jumped to step 3 when I forgot to state my restrictions. A cannot equal 0, B cannot equal 0. A can't be 0, B can't be 0, B can't be 0, A can't be 0, B can't be 0. Alright, good. Phew. I remembered. Okay. Now that we have a common denominator, we can add or subtract the numerator. In this case, subtract. So we get AB squared plus 2 minus AB times B plus 2 all over 2AB squared. Alright, I'm going to have to take it down the side here. Let's expand this out. We've got AB squared plus 2 minus AB squared minus AB times B minus 2AB. So AB squared and AB squared are going to cancel all over 2AB squared. What I have on the top here is getting kind of messy. 2 minus 2AB all over 2AB squared. Can I factor anything? I can. I can factor at the top. 2, 1 minus AB over 2AB squared. 2 and 2. Finally, at my final answer, 1 minus AB over AB squared. A cannot equal 0, B cannot equal 0. Sorry. So for this example, we need to find a common denominator between x minus 3 and x plus 2. And there is no common denominator. What we're going to have to do is multiply the first fraction. We're going to have to multiply it by the denominator of the second one. But whatever you do to the bottom, you got to do the top. And for the second fraction, second rational expression, we're going to have to multiply it by the denominator of the first guy. So what's the denominator of the first guy? X minus 3, x minus 3. Now that we have all that, let's do some expansion. I know that I'm going to have x plus 5, x minus 2, plus 2, plus x minus 7, x minus 3, all over a common denominator. X minus 3 and x plus 2. Alright, so that looks gigantic, but okay, so far so good. I am not going to expand my denominator. I'm going to leave that as factored. I will have to expand the numerator. We've got 2 terms here, plus another 2 terms being multiplied by each other. So let's do FOIL and expand this first bracket, pair of brackets. We get x squared plus 2x plus 5x, so that's a total of 7x plus 10. Let's do the second bracket. 1, 2, 3, 4. So what do we have here? X squared minus 3x minus 7x, negative 10x, positive 21, negative 3, negative 7, all over x minus 3, x plus 2. I should write my restrictions. My favorite thing in the world. What are restrictions? Well, here I can see that x cannot equal 3 and x cannot equal negative 2. Let's go back. X squared and x squared, 2x squared, 7 minus 10, and 10 plus 21, 31. So now I should be looking for 2 numbers that multiply to 62. So we need 2 numbers that multiply to 62 and add to negative 3. Alright, so are there any numbers that multiply to 32 and add to negative 3? Nope. This is it. So the restrictions on the variable again are x cannot equal 3 and x cannot equal negative 2.
Alright, for this last example, there's a typo. On your sheet, this sign right here is a negative. I need you to change it to a positive. Please change this to a positive. Done? Excellent. Okay. So first step is to factor. Can we factor anything out of the top? Nope. How about the bottom? Well, we need two numbers that multiply to negative 48 and add to positive 2. That would be x plus 8 and x minus 6. For the second part, can't factor anything out of the top. For the bottom, we need two numbers that multiply to negative 30 and add to negative 1. X minus 6 and x plus 5. Alright, do we have a common denominator? No. Do we have a denominator that has something in common? Yes. Both denominators have x minus 6 as one of the terms. If both denominators have x minus 6, if I need to add, what's missing here? Well, I really need this to have an x plus 8. If I do that to the bottom, I gotta do that to the top. And this one needs an x plus 5. If I do that to the bottom, I gotta do that to the top. Alright, so now my common denominator is x plus 8, x minus 6, and x plus 5. It's 5 plus 8, there, all the same. So my giant common denominator is going to be x plus 8, x minus 6, and x plus 5. My numerator is going to be x plus 9, x plus 5, minus x minus 9, x plus 8. Before we go much farther, let's get some restrictions. Well, x cannot equal negative 8, positive 6, and negative 5. Now that's out of the way, let's FOIL and expand here. So we have x squared plus 5x plus 9x plus 45. We're going to take away another FOIL. I notice that I have a minus sign outside of these two brackets. For me, if I had a minus sign or if I have a number in front of these two monomials, I'm going to put a set of square brackets and put all my answers here, and then in my next step I'm going to distribute the negative. X squared plus 8x minus 9x minus 72. Still all over x plus 8, x minus 6. Sorry about that. So we have all of this over our common denominator x plus 8, x minus 6, and x plus 5. Let's distribute the negative. X squared plus, there we have 14x plus 45 minus x squared minus, well, positive 8 minus 9 gives us negative 1. Negative 1 times negative out here gives us plus 1x. Negative, negative, positive 72. Same denominator. Next step is to combine like terms. X squared minus x squared, those are 0. 14x plus 1, 15x. 45 plus 72, 117. And denominator stays. Is there anything that we can factor on the top? Nope. So x cannot equal, what were our restrictions? Negative 8, negative 5, and 6.